Hello students, welcome to Spectra Education Academy. In this video, I am going to explain answers for few previous NEET questions from the chapter System of Particles and Rotational Motion. Let us start with the first question. A uniform circular disc of radius 50 centimeters at rest is free to turn about an axis which is perpendicular to its plane and passes through its center. It is subjected to a torque which produces a constant angular acceleration of 2 radian per second square. So we need to find out the net acceleration in meters per second square at the end of 2 seconds approximately. So this is given in 2016. So when a particle moving in the circular path, the particle possesses angular acceleration due to change in the angle, linear acceleration due to change in the direction of tangential velocity. So let us say this is the velocity, tangential velocity. Of course, this velocity changes its direction. So therefore, in this direction, there will be tangential acceleration. Even there is also one more acceleration that is towards the center. We call it as centripetal acceleration or normal acceleration. So therefore, these two are at an angle 90. So let us write A net is equal to, making use of parallelogram, A square is AC square, centripetal acceleration, B square. So B square is tangential acceleration. This 2AB cos theta term in parallelogram does not exist because theta between AC and AT is 90. So cos 90 is 0. Now let us try to find out AT first. Relation between AT and angular acceleration, because in the question angular acceleration is given R alpha. R is given 50 centimeters, converting into meters, -2. Alpha is 2. 2 into 50 is 100 into 10 to the power of -2. So therefore, this becomes 1. Now, so centripetal acceleration. So centripetal acceleration is, we can directly write it as V square by R. So we need to concentrate on getting the value of V. So therefore, we can write that this is going to be R omega square, R square omega square divided by R square. R is equal to centripetal acceleration. Yeah, we can cancel R and R. So let us try to get omega, making use of omega 2 square minus omega 1 square is equal to omega 2 minus omega 1, because T mentioned in the question. So better to go with omega 2 minus omega 1 is equal to alpha T. So this is similar to V equal to U plus AD in translatory motion. So omega 2 is equal to, starting from rest, alpha is 2 radian per second and time is going to be 2 seconds. So therefore, omega is going to be 4 radian per second square. Now this is going to be, here there is R and omega. So therefore, AC is equal to, R is once again 50 centimeters into 10 to the power of -2 into. So there is omega square, omega is 4. So therefore, this is going to be 16. So next, AC is 16 by the 80. And this is going to be 800 into 10 to the power of -2. Zeros are cancelled. So AC will be equal to 8. So now looking for net acceleration. Net acceleration is AC square. So AC square is, AC is 8 means 64. 80 is 1. So this is root 65. So root 65 is close to 8 only. So third option is correct. Moving to the next question. The disc and sphere of same radius but different masses roll off on two inclined planes of the same altitude and length. Which of the two objects gets to the bottom of the plane first? So let us try to find out time. The question is focused on time only to determine. So for that, we need to write acceleration equation. A is equal to G sin theta by 1 plus K square by R square, where K is the radius of gyration radius of gyration. Now, so the equation of radius of gyration will be different for different substances. In case of disk, so mk square is equal to mr square by 2. M and M get cancelled. This is for disk. In case of sphere, mk square is equal to 2 by 5 mr square. So once again M and M get cancelled. This is for sphere. So therefore, making use of V is equal to U plus AT. In case if we treat starting from rest, so T is equal to V by A. The expression of acceleration is this, V by G sin theta. The denominator quantity will go up, K square by R square. So if we substitute T disk, so therefore V by G sin theta will continue. Then this is K square for disk is R square by 2 divided by R square. This and this get cancelled. So this is 3 by 2 V by G sin theta. Next, for the case of sphere, same expression, V by G sin theta, 1 plus K square is 2 by 5 R square. So divided by R square. So is equal to V by G sin theta. So this is going to be 7 by 5. So 7 by 5 is roughly 1.4 and 3 by 2 is roughly 1.5. So therefore, T 7 by 5. This is 1.4. This is 1.5. Then, so sphere reaches within 1.4 seconds. Okay, take this V by G sin theta constant, whereas disk takes 1.5. So therefore, sphere only reaches the bottom first. Moving to the next question. From a disk of radius capital R and mass m, a circular hole of diameter capital R, whose rim passes through the center is cut. What is the moment of inertia of the remaining part of the disk about a perpendicular axis passing through the center? So try to understand. So this is a disk from which diameter R is cut. So we can understand like this. So first let us write the moment of inertia of the remaining disk is equal to moment of inertia total before we cut and moment of inertia of the removed disk. So this is before we cut. This is removed part. So first let us concentrate on removed part. So concentrating on removed part means we need to find out what is the mass of the removed portion. So let us say dm by area small a is equal to total by capital E. So therefore dm is the mass of the removed portion. So let us write this is pi r square. Thus the removed portion is having diameter r. So diameter r means, so this will be 2r is equal to r. So therefore this is equal to m by pi r square. This is area. Then let us concentrate dm. So pi and pi get cancelled. R is r by 2. So r square will be what? R square by 4 is equal to m by r square. R square and r square get cancelled. So the mass of the removed portion dm is equal to m by 4. Now, so the moment of inertia of the remaining part of the disk about a perpendicular axis passing through the center. So therefore, so this may be the axis. So let us find out the moment of inertia of the removed portion first. It is nothing but I plus mx square. So m dm with r square. This dm we are going to substitute m by 4. And since it is a disk, so the axis moment of inertia about an axis passing through center is m by 2 r square plus mx square. So therefore, this is dm. Then this is going to be m by 4 multiplied with 2. So radius is going to be r square by 4 plus once again dm by 4. dm is m by 4. X is, if diameter is 2r, so x will be r by 2. This is going to be r square by 4. Then here 832. 32 will be the LCM. Then mr square. This is 16, so 2mr square. So altogether this is 3mr square by 32. Now, so remaining portion is total minus removed. So therefore, total is m by 2 r square minus 3mr square by 32. So the LCM is 32. This is 16mr square minus 3mr square. So the answer is 13mr square by 32. So fourth option is correct. Moving to the next question. Question number 4. A solid sphere of mass m and radius capital R is rotating about its diameter. A solid cylinder of the same mass and same radius is also rotating about its geometrical axis with an angular speed twice that of. So therefore, angular speed of the cylinder is twice that of the sphere. Ratio of the kinetic energies of rotation. So therefore, you need to find out rotational kinetic energy to the sphere to the rotational kinetic energy of the cylinder. So get back the formula. Half I moment of inertia of the sphere, angular speed of the sphere whole square divided by half moment of inertia of the cylinder with angular velocity of the cylinder. So therefore, half and half get cancelled. So moment of inertia of the sphere about an axis passing through diameter is 7 by 2 by 5. First case 2 by 5 mr square with omega sphere square whole divided by cylinder is like a disk first case mr square by 2, but they mentioned omega cylinder square is equal to 2 times of, so it will be 4 omega sphere square. So this and this get cancelled, mr square get cancelled. Then this is going to be 2 by 5 whole divided by 4 by 2. So then this is going to be 4 by 5 into 4. So 4 and 4 cancel. So answer is 1:5. Second option is correct. This is given 2016. Now question number 5. A light rod of length L. So say this is the light rod of length L. Masses M1 and M2 are attached here at the ends. The moment of inertia of the system about an axis perpendicular to the rod passing through the center. So Roughly this is center, and so the two particles are rotating about this particular axis. Remember, in case one mass produces clockwise movement, other mass produces anti-clockwise movements. So torques are same. Tau1 is equal to tau2. So tau is R1 with F1 is equal to R2. This is a perpendicular distance with F2. So R1, this is M1G, is equal to R2 with M2G. GG get cancelled. So we can also write. So let us say that from the center to the first mass, R1 is the distance. From the center to the second mass, R2 is the distance. So we can say L is equal to R1 plus R2. So we can write R1 is equal to L minus R2. So therefore, this is to obtain R2 for R2. Similarly, the same equation, R2 can be written as L minus R1. This is to obtain R1. Okay, so therefore, suppose if R1 is replaced with L minus R2, M1 L minus R2 is equal to M2 R2. So therefore, if you take M1 R2 right side, take out common R2. So you will get M1 plus M2. Left side you will be left with M1L. So therefore, R2 is equal to M1L by M1 plus M2. Similarly, just imagine R1 will be equal to M2L by M1 plus M2. Now our focus is on to find out moment of inertia. I is equal to M1 R1 square plus M2 R2 square. So M1 R1 square is M1 square L square divided by M1 plus M2 whole square plus there is M2, but R2 square is M2 square L square divided by M1 plus M2 whole square. So if you simplify this, this is M1, you take one M1 square here. This is M1, this is going to be R2. R1 is this is with M2. This is with M2, this is with M1. So M1 and M2 you take here, then L square, denominator M1 plus M2 whole square. So there is still one M2 is left here. There is one M1 is left here because after you take M1, M2 common, there will be M1 plus M2. So this term and this term get cancelled. So therefore you will get the answer M1, M2 L square by M1 plus M2. So therefore first option is correct. Next, moving to the question number 6. Two rotating bodies A and B of masses m and 2m with moment of inertia Ia and Ib have equal kinetic energy of rotation. So if LA and LB be their angular moment are respectively, then so get back the relation rotational kinetic energy and angular momentum are related like this. Why? So they said kinetic energy of rotation same. So now L square is proportional to I because L square is at the numerator, I is denominator. Therefore, what we can write is L square is equal to L1 square by L2 square is equal to I1 by I2 since they are proportional. So what we can write is L1 square by L2 square. Moment of inertia can be M1 R1 square divided by M2 R2 square. Okay, so therefore M1 is M, M2 is 2M, R square by R square. So therefore this and this will cancel. Therefore you will get L2 square is equal to 2L1 square. So L2 will be equal, L2 is equal to root 2 L1. So therefore L2 is only greater. So L2 is greater than means what? LB is greater than LA. So third option is correct. Next, which of the following statements are correct? Question number 7. Which of the following statements are correct? Center of mass of the body always coincides center of gravity. No. So in case of asymmetrical bodies, do not coincide. A center of mass of the body is a point at which the total gravitational torque on the body is. So due to weight of one body, there may be clockwise momentum produced. Due to weight of the other body, anti-clockwise momentum produced. In case if both are balanced, so therefore net torque will be 0. So this statement might be correct. A couple on a body produces both translational and rotational motion. No. So couple never produces translational motion. Only it produces rotational motion. So this statement is wrong. Mechanical advantage. Get back the formula of mechanical advantage. It is load by effort. Or otherwise there is another formula, effort arm by load arm. So therefore if mechanical advantage greater means definitely effort will be small because these two are inversely proportional. So therefore both statement 2 and 4 are correct. Fourth option is correct. Then moving to question number 8. A rope is wound around a hollow cylinder of mass 3 kg and radius 40 centimeters. The angular acceleration alpha is the question. In case the rope is pulled with a force of 30 newtons. Okay. So just imagine the situation. Rope is wound around a hollow cylinder. So this is hollow cylinder. So mass is mentioned 3 kg. So radius 40 centimeters. So we need to find out angular acceleration. So R perpendicular with F is equal to I alpha. This is torque. Then R perpendicular. This is F is mentioned in the question. Moment of inertia of a hollow cylinder. So is mr square with alpha. One R get cancelled. Then this is going to be 30 is equal to mass is 3 kg into 40 into 10 to the power of -2 with alpha. So therefore this is 10 times. So 10 by 40 into 10 to the power of -2 is equal to alpha. This will be 1000. So 1000 by 40 is 25. So alpha is 25 radian per second square. So second option is correct. Next. Two discs of same moment of inertia rotating about their regular axis, passing through center and perpendicular to the plane of disc. The angular velocities omega1 and omega2, they are brought in contact face to face coinciding the axis of rotation. The expression of loss of energy during this process is. The formula for the question, loss of rotational kinetic energy is half I1 I2 divided by I1 plus I2 with omega1 minus omega2. So similar formula in the collision also you have. This is M1 M2 by M1 plus M2. This is the formula for loss of kinetic energy in case of collision. So it will be V1 minus V2 whole square. So now both are discs only. Moment of inertia same. Half into I square divided by 2I with omega1 minus omega2 whole square. So I and I get cancelled. The answer is 1 by 4I omega1 minus omega2 whole square. So moving to the next question. This is based on torque. Moment of force F given at a 2 at coordinate 2 comma 0 comma minus 3 about the point 2 minus 2 and 2 is given by. So therefore torque is equal to moment of force or torque is equal to R perpendicular with F. Otherwise you can also write R cross F. So first R perpendicular can be written as R sin theta into F. So R cross F. So therefore now, so let us try to find out position vector. Yeah, so it will be R2 minus R1 is the position vector is equal to treat this is second position and okay minus R2 plus R1. So is the going to be the position vector. So this is second position is 2i minus 2i plus 0j minus 3k. So this is the first position. We are subtracting second position from the first position minus. So this is 2i minus 2j minus 2k. So 2i minus 2i plus this is 2j. This is minus 3k. This is plus 2k. This is plus k. These two get cancelled. So therefore R. Now let us go with the cross product. I, j, k. R is going to be 0, 2, 1. F is given 4, 5, minus 6. So this is going to be I of. So this is minus 12, minus 5, minus j of 0, but this is minus 4 plus k of. So this is 0, but minus 8. So this is minus 17 I cap. This is plus 4j cap plus 8k cap. Yeah. So minus 17. Once again you check this. This is minus k because 3k minus 3k plus 2k. So therefore it's minus k. So therefore this is minus 1. Therefore this will become plus 5. And in the case of even j also, even j also, so this is 0. This is going to be minus 4. Minus become plus. So therefore this is minus 4j. And in the last case it is plus 8. Sorry, this is 0 but minus 8. AD minus BC. A, B, C, D. AD minus BC. This is minus 8. So therefore, fourth option is correct. Moving to the question number 11. Moving to question number 11. Yeah. A solid sphere is rotating freely about its symmetry axis. In free space, the radius of the sphere is increased, keeping its mass the same. Which of the following physical quantities would remain constant for the sphere? So therefore, angular momentum remains constant. So because angular momentum is involved with mvr. So what they mentioned, radius is increased, keeping its mass same. So therefore, if radius increases, there is change here. But finally, there is change means you can say that V may be decreased. V may be decreased or may be increased, but total angular momentum remains constant. So therefore, angular momentum remains constant. So students will continue in the next video the answers of the remaining questions in the same chapter. Thank you very much for watching my video, but don't forget to share and subscribe with your friends and relatives. Thank you very much.